Oh yeah, I'm super excited to be here today. This is a presentation, or the first half of the presentation is a presentation I gave at the first annual 2022 Stream Restoration Conference. And the second half is probably a preview of what I'm talking about this year. So this is a great chance for me to get some input that will help round out my presentation for in August. So, streams are pretty challenging in urban settings, and I've been working in urban settings since, I think I did my first project in early 2000s, like 2002, 2003, and certainly have learned a lot about working in urban environments. So I always start this presentation with, how many of you own a drill, right? I think that's pretty close to the drill I own. I own a DeWalt drill. It's pretty nice, variable speed, to classic, bought it at Home Depot. But the funny thing is, none of us need a drill. It's the most useless thing ever. What we really need is a hole. But really, we don't need a hole. What we really need is a bookshelf or whatever we're going to use to build that hole. And I think the same thing can be said about streams, right? We talk so much about variable riffles and crossfades and toe woods and log riffles and all the cool things that we like to design, and geomorph, and 4-stage channels and whatnot. But we don't really need any of this. What we need in urban environments is clean drinking water, water for our businesses. We use our streams to travel. We love to fish and recreate in them, grows our food. And the bottom right picture there is, we've been using these streams there. But it's really funny. I mean, I know this, to get a little bit of this river share is also about sort of finding ourselves. And this is a great book, if you haven't read it, called Blue Mind. And it basically talks about, we are just naturally wired, like our lizard brain, the lowest, most part of our brain, the neuroscience of us is that we know deep down we need to be around water, right? It's just, we start our lives the first 9 months in our mom's womb, which is water, and we just know that water is life. And so, I'll read this quote from the book. We are naturally inspired, calm, and just generally made happier by being on or around water, playing in it, walking next to it, hearing it, painting it, fishing it, writing about it, and creating memories around it. And for this group, working with water, right? So I think that's pretty cool that it's just like, when we get around water, we get calm, right? And that's so cool that we do that. But we've known this since the beginning of time. And, literally our earliest cities, Mesopotamia, which actually is the word for two rivers, is, founded between two rivers, the Tigris and Euphrates. But other than that, I was trying to think of a city in the world that probably didn't share this, or civilization, or early civilization. And I'm in Colorado, so Mesa Verde is a cliff dwellings, but the cliff dwellings just magically disappeared, and probably because they weren't close enough to water. So, I like to joke that that's a picture of Denver there, which is Cherry Creek and the Platte River. When I was in Charlotte, it's Little Sugar Creek and Irwin Creek. Charlotte's in between. I grew up in Winston-Salem, that's Salem Creek. Been doing some work in Tucson, that's the Santa Cruz River. So no matter where you are, the LA River, no matter where you are, I think water's the theme of our urban settings. So, that's why the cities are there. That's the lifeblood of our cities. People talk about the city square is the center of our cities. BS, rivers are the center of our cities. So what the hell happened, right? I like to say we started, I like this quote at the bottom. We steer the boat, we didn't alter the river. I don't know who Jay Earp is, but he didn't know a civil engineer that had access to concrete. And we've altered the crap out of our rivers over the years. And we lit them on fire, which was the catalyst of the Clean Water Act in Cleveland. LA River there, that's a picture of a stream in Atlanta, Georgia, that we basically daylighted. So we've really done a mess. But I get it, right? We all get it. We especially those of us on the engineering side, streams, and me and Josh were just talking as the call was getting going about flooding, and streams being high because of the snow melt in there. I saw some flood warnings recently up in Loveland and stuff from the snow melt and the recent rainfalls we've gotten. And streams are very dangerous. We think of them as a hazard, but then also streams are an awesome part in the front yard of our city. Again, that's right. Picture I took this summer or last summer up in on River Days there in Denver, which you see the stage set up, you see the people, everybody rafting, all the kids swimming in the river. So we have this thing where rivers are danger and rivers are joy, right? And so we kind of forget that. We have to manage both ends of that spectrum. But I think for a long time in the early 1900s, we were just managing rivers as conveyance and just risk. So I think we've realized this, and there's so much in the news going on. Here's just some recent articles in the last couple of months that I pulled, just did a Google search, clicked on news, and these are some articles that popped up. LA River gets 28 million from the infrastructure law. South Platte, for those of you in the Denver area, just combination of core money and Denver money is going to invest $500 million there. Fairfax County, top right. How daylighting buried waterways is revitalizing cities. I think this is in Missouri. Toby Creek, that's a project I worked on through the campus of UNCC, an opportunity for learning. So just there's this desire, I think, to re-engage our rivers in these urban environments. So like why we're doing these projects is, this is what I always think, this is Simon Sinek's golden circle, where why is at the core of everything you do. You go out the process of how you do it, and then you go out to what, and the results of what you do it. And I think it's good. I think we've got some good clarity that we need to restore our rivers in our cities, and there's tremendous investment in this. Unfortunately, the process and how we're doing this work, it needs some work. I think we all on this call recognize this, and that we need to share results and we need to do a better job. So not that there's not a ton of great design manuals and research out there, right? I mean, these are just some recent ones, some of these projects I've worked on, where I was looking back through some references and some design manuals or functional assessment manuals I use, and these are some that I've used recently. A lot of these are for arid, semi-arid Southwest, because I've been doing some work out in Arizona. But you got the Utah stuff that's come out recently, low tech process space. One of my go-tos is the NRCS manual. But it's funny, us as an industry aren't really working as much. I've been fortunate, I love working in urban streams, but we haven't been working as much in urban streams. Streams are really a best management practice for managing water quality and flood control in streams, right? Or in cities. So why aren't better guidance for engineers who are touching these streams and working in these streams in places that they're used to going? Why aren't they in the North Carolina BMP manual? I mean, this is infrastructure of our cities, is the stream. It's the green infrastructure, but it's the infrastructure that's critical. It's no more or less critical for designing urban infrastructure a stream is than a road or a wastewater treatment plant or a pond or a stormwater BMP. But you cannot find how to design a stream in any urban design guidelines. Or if you can, it's probably 10 to 20 pages of mention of it. So we really are failing here, I think, to get information into the hands of the engineers that are working in cities. And as a result, we're getting a bunch of concrete channels or a bunch of drop structures with grout or a bunch of sheet piles that are all in the streams. So this is really just messing up our streams, and it's our fault, right? And this is still a new science. And so I'm happy for the River Share and the National Stream Conference and all the sharing that's going on now. And hopefully we can move to this. So, just by comparison, I think it's interesting. People are like, oh, streams are different across the country. There's no way there could be a national standard or some national basis of design. I disagree. I mean, roads are different all the way across the country. A road in Florida is way different than a road in Colorado, or a road in Minnesota because of the snow. It's got to be way different than a road in Texas. But there's still a national guidance. And if you're a roadway engineer, if I've ever worked with a roadway engineer, their go-to book, they call it the Green Book, is the AASHTO Geometric Design of Highways and Streets, right? And what they did, obviously designing roads has been in cities and counties, is they got together and said, what's the critical thing? So in absence of a local criteria, at least there's a national criteria. So 18 state departments of transportation, National Association of County Engineers, National League of Cities, American Public Works, they all got together and they have a committee that does this, and they update it, I think, about every 5 years. Don't quote me on that, but I think that's right. And could we do something like that for streams? It could be a basis of at least some foundation, and then you could cater that to your local criteria. I mean, there's still the Colorado DOT manual for designing roads. There's still the North Carolina DOT manual for designing roads. There's still the City of Charlotte manual for designing roads. So they're still layered on top of this, but most of them will reference back to, as I said, the Green Book. So could we move there? And this is my presentation that I gave at the last stream conference. And so I was like, well, if I'm going to say we need to do this, then what are some things I would do? I'm sorry, I can't try to. So I would start with, if I was to suggest some things for this book, is the biggest thing I see with problems is funny. I'm one of our lead stream people for our Kimley-Horn, and we have 120 offices around the country, 7,000 people, and I get pulled into projects all the time, and they'll be like, hey, we got this project. Our client, city of blank in Texas, for example, wants to restore this stream in the city. And I'm like, cool. Why do they want to do it? And they're like, well, they want to restore it. I'm like, well, why do they want to restore it? So we really got to work on our clear goals and objectives. I mean, we've got a lot of functional assessments out there now that I like, but is it for flood control? Is it for water quality? Is it for both? Is it for recreation? Is it for an amenity? Is it for fisheries? What are the driving reasons of your why? To go back to my why. I mean, it's cool. I agree. We should restore all our streams in our cities, but we got to have clear goals and objectives. And I just see us really failing there. This is a project in Charlotte that's through the campus of UNC Charlotte, University of North Carolina, Charlotte, that was about 10,000 feet, restored that. So we had objectives that mixed in water quality, slope, hydraulic function, but also a lot of stuff that just made it an amenity to the campus and an educational tool for the university to use in the decades to come. And this project has been very well received. I think it's been very well received because we built it during COVID. So if you ever need to work on a project in a really busy campus where you're worried about killing students with equipment, just shut the campus down using a national pandemic and you can get your project built without anybody criticizing. So the next one I would say, this goes with goals and objectives, is can we solve $3 of problems with $1? And I think with cities, there's such a great opportunity to do so many things with our urban streams. We can solve flooding with good stream restoration. We can solve water quality. We can solve there. And so there's a lot of stuff out there that's outside the stream world. This is a pyramid I like from the Millennial Ecosystem Assessment, and this defines the 4 categories of ecosystem services that contributed to human well-being. And they're regulating, so that's air quality, climate, water, certainly can affect that. Supporting nutrient cycling, water cycling, soil formation, certainly can affect that. Provisioning food, fiber, biomass. Maybe some of these urban stream corridors, I mean, we have a huge hunger problem in the US. Maybe we can use some of these floodplains as the way we've always used them and to support agriculture and urban farming. And so freshwater and natural medicines, ethical values. I think all of us share that ethical value of the river. I heard a cool story where public involvement, when they were talking about what they were going to do on their project, they left an empty chair, and that empty chair represented the river, right? I thought that was super cool. Like, hey, the river has a seat at the table. Existing values, recreational tourism. So here's some photos. The top left here, this house. This was when we were building Little Sugar Creek, which is this photo. I got this email, or our project manager for the city, I was copied on it, got this email from the homeowner during, this is Hurricane Florence, which is the highest gauge of record, or the highest flow of record since they've been had a gauge out here, which is 20, 30 years. And when you see this picture attached to an email, you're like, this person's gonna be mad. This kid has a boogie board in their front yard. So this might not be a good thing. And he was just like, this is the best project ever. This is the least amount of flooding we've ever gotten. I'm so excited. Used to, the water came up to my front step or onto my porch every time we get a big rain. So that was pretty cool. Obviously, greenways, we love greenways as a society and as cities. Charlotte is building out a great greenway system. Denver has a great greenway system. Almost every city has a greenway program. It's great. Do your restoration. Think about where your haul roads are going. You're compacting that as you go. Come back, add a greenway where your haul road used to be, and see if you can time that out. Also makes it way easier to do roads. Out in the Mountain West, this is a project. This is the Santa Cruz River, and this is Tucson. Tucson, obviously, Mountain West gets a ton of fire. We're working on a river management plan on Santa Cruz, and a big part of that is removing salt cedars. Salt cedars are a huge source of fire, really easy to burn. and then turning those river corridors back into fire breaks, which, more willows and native species, mesquites that will help be more resistant to fire and create some fire breaks and not be a source of fire like salt cedars are in those river corridors. So working with Pima County Flood Control and the Audubon Society and several other partners to work on that, and hopefully get to do some ecological restoration. As an East Coaster, this project blew my mind. Base flow is 0, other than at the wastewater treatment plants where the water comes out, and actually that's bringing back some native fish because they've upgraded the plant to a Class 8 effluent. So, Wilhelm's pyramid of hydrology at the bottom, you can actually restore hydrology with stormwater or with wastewater outfalls and have a base flow, and brought back some endangered species. The Hilo top minnow came back there, and but 0 base flow. I think Q100 is about 70,000 CFS, 3,000 square mile watershed. So figuring out the geomorphology, or if it even has a geomorphology of a system like that's been a fun project. Floodplains, we need to love them, protect them, restore them. This is the biggest thing we can do. This is a map in Valentine. You see Charlotte, North Carolina. You see the floodplain, really good floodplain ordinance. You see the subdivision just wrapping around and all the lots backing up to the floodplain, but protecting it. Here's a nice greenway. Here's a picture of it. This is a really active floodplain where the stream is connected to the floodplain. So this is just a math problem, folks. I mean, if we lose these floodplains or don't restore them, we're never going to catch up. So here's a quick math. So this is 1.2 miles with, I delineated this, about 80 acres of floodplain. I was generous and just said, after a given rain, there's maybe 3 inches of water stored. That's probably low, but we'll just do it. That's 6.5 million gallons stored, like almost like it's acting like a detention pond, or treated. It's after the rain event. You see here the ponding, it'll infiltrate back into the soil and return to base flow. So, people love green infrastructure, love nature-based solutions, love low impact development. So if we lost that 1.2 miles, or if we could restore it, that's replacing 500 to 700 bioretention basins. That's 1 mile, just over 1 mile of streams. There's 3,000 miles of streams in city of Charlotte. So that would be what, 1.5 million bioretention basins in one city we would need if we lost the floodplain functions, just to sort of bring that up into the uplands. That's not happening. That's not feasible. So what's way feasible is to protect our floodplains. And if we haven't protected them, start buying them out and returning them back to floodplains. And you can do this. Here's a good picture. This is in Davison, North Carolina. You see a super incised stream, me standing in it. Jason Diaz, one of my colleagues at the top, and that's our client now standing where I was standing. This is the exact location, and Jason standing where he was standing. We brought the stream up, brought the floodplain down, and over time this will return back to an active floodplain and hopefully get some good riparian vegetation and wetlands. You see the juncus has already come back really nice right after construction. The other thing I think I'd propose is there's so many people who don't understand the difference between a threshold channel and alluvial channel design. These are 2 different chapters in the NRCS design guidelines, and I think they're misused. I'll review a set of plans for others, and there will be all this talk about sediment transport modeling and I look at their watershed, and the whole watershed is developed. The top of the watershed's piped, paved, and I'm like, where is that source of alluvium coming from? You've gotten rid of it all in these urban settings. So really, you're wasting all this money doing this thing when you're really dealing in a threshold channel, which means you're going to have to build your ripples. That's not all the way to the case. I was super cautioned, but there needs to be thought. This project at the top is a alluvial system, super dynamic, beds super active. You see the stream actually created an avulsion, took out and started running down the sewer line. That's why we had to intervene and move it back over to where it was. But I would say for the majority of smaller systems, they're mostly thresholds, but there's no such thing as a fully alluvial channel or a threshold channel. There's always mixing in both. And so good thought process there. This is a project that we came in and did a repair on. It was designed by others, and it made me think. We sort of did a forensics case of like, why did this stream fall apart? I know the firm that did this, they're excellent hydraulics engineers, really good at what they do. They're great modelers, but they don't really have a stream expertise. And so I think there's a couple of pictures of this, and I'll go through one. we want to have a meandering stream and create these super meandering streams, right? But then we'll see this structure here. See this picture here at the top left? That's a triple drop structure right in a tangent section. So they created this super sinuous stream, and then they put a step pool right in the middle of it. Well, those two things aren't really the same, right? You can't have this riffle pool sequence stream design and then throw a step pool right in the middle, because if you do that, you're mixing two design methodologies, and so you're messing up your pool to pool spacing there. And you see the results here below, just unraveled. There's some other stuff they did. We actually took out meanders and turned it back into a riffle pool sequence, made it less sinuous, and got rid of these big drops. There was so much of these giant rocks. So there you see the fix, not very sinuous. And then you also kind of see the context of the urban watershed that it's in, with, you know, everything above it is pretty much piped. And this is definitely like the first part of the stream that's daylighted. This project is actually called City View, and all the regulators and clients and everyone involved in it called it Shitty View. So that's not a good sign when you are trying to get mitigation credits and everyone hates it. So it's doing really well now, but there again, I don't think they did anything wrong. I just think there was something, and more and bigger is not always better. So, you know, they kept putting bigger rock, more meanders, trying to flatten the slope with sinuosity, and it just was not the appropriate geomorphic setting for that. So, you know, we couldn't even haul off all the rock because it was getting too expensive. So we, you know, I don't like putting rock toes in a project like this, but we just buried a little bit in the rock toe there to burn some rock and get it out of the riffles. So that's one that I would say. I think we try to mix, and I know out west here, Dave can probably attest to this, is, you know, we'll see this meandering nice stream, and then they'll throw a grouted rock grade control structures with a 4-foot drop right in the middle. And all of a sudden, by doing that, they've moved the stream, they've created a step pool right in a tangent section, and they messed up the slope. And that brings me to my next point. So understanding momentum, velocity relative to geometry, and resistance for your system. If we're doing a threshold design, then we're probably looking at sort of where are our maximum, what's our range of velocity and shear stress and Froude numbers that we can work in to be stable. And we'll get lazy and we'll pull a lot of these from, I wouldn't say lazy, but we're just taught this way as engineers. We'll pull a lot of these from values. So, and a lot of these values come from the U.S. Army Corps of Engineers, Wastewaters, Vicksburg, Mississippi experimental station, where you'll see stuff like 5 feet per second, 7 feet per second, if it's this type of soil. And I'm okay with those as a starting point, but we have too good of like HEC-RAS modeling and LiDAR and 2D modeling now, where we can really understand through references, like what is the thing. So, you know, here's the design parameters out of a local manual I pulled, and it said maximum 100-year depth outside the floodplain 5 feet, maximum 5-year velocity 5 feet per second, maximum 100-year 7 feet per second. This project here, this is a 14-foot water column depth. You're in that same hurricane I showed the flooding from on the property. So the water's 14 feet deep here. Here's a couple days later to the right, no damage. This is actually during construction. You can still see our hollow road behind the towers there. So, you know, I disagree. I think you need to kind of understand it for yours, because what I think happens while we have so much giant boulders and grouted streams and stuff, is we use these very conservative numbers, or sometimes they're overly conservative, and we screw up and we put rock where we shouldn't put rock, concrete where we shouldn't put concrete, or vice versa. We think we're going to be stable and our stream unravels. All right, here's a little controversial one, and I'd like to hear feedback on that. Return intervals should be used to assign risks, not to design storms. I said this at the Colorado Association of Stormwater and Floodplain Managers, and I think I made the room's head explode, because the criteria here in Colorado is that most people are used from is minimum bank flow capacity, circled here, of a channel based on future development conditions, 70% of the 2-year discharge and 10% of the 100-year discharge, whichever is greater. Well, if we over design channels, we've instantly built an incised stream. And we all know if we build an incised stream, it's going to instantly unravel. So using something like this can make our channels too big. We make our channels too big without access to a floodplain, and they unravel. So here's my example. This is during our construction of Little Sugar Creek, we have a USGS gauge, again, tons of great data. There's our bankful line, is about 4.5 feet was bankful at the gauge, and we got 20 bankful events in 1 year. So did we call bankful wrong, or is the return interval in North Carolina, you'll hear it 1.2 year storm. Now I did a project just up the hill or just upstream in Concord, which is 1 county over, still Piedmont, North Carolina, same geology, same climate, still rainfall thing. And based on that watershed, I did get it around the 1.2 year storm when we back calculated return interval. So starting with return interval is wrong. Back checking return interval in urban settings is right, because you do need to know what is your floodplain and where are you putting water, because you do have people living along it and you do have risk. So I can't overstate this one enough. I think this is really screwing up a lot of projects and a lot of bad guidance out there. So in my green book of stream restoration, I would make sure people stop using return intervals to design stream. You know, you're gonna go 2 year storm, you're gonna go 80 percentile storm. Streams are based on geology and rainfall and sediment budgets, has nothing to do with return interval, in my opinion. It's a momentum and velocity issue in most of these. So this leads us to multi-stage channels. I won't talk too much about that. Urban curves, another controversial ones. This goes back to my same thing. You know, originally I think there was this mindset that, well, in an urban environment, the curve shifts up, channels get slightly bigger and there. And so that project I was showing, the City View project, they used the urban curve, and I believe they started off their channel in size. They were too deep, too wide, too much area there. You know, I've worked on this curve here, Piedmont Rural, North Carolina, for 15 years or however long it's been published. And we've consistently found that the streams in urban environments in the Piedmont fall right on that rural curve, and not even regardless of the setting in urban. And again, looking at my graph, what happens is area stays really consistent and bankful frequencies just increase. We've been looking, and I haven't vetted this out, it's still kind of thing. I don't know if anybody else has looked at it, of trying to put curves together for low flow. And we found pretty good consistency in low flow geometries. And I think we need some help there, because the picture on the right is, you know, you walk out to a stream and you'll look at something like this and you're like, what is base flow? And really hard in urban environments, because you've got this impervious, which is prevented groundwater inputs, and you have less base flow at times, way less. And then you have more base flow or quicker, flashier events. So how do you do that? And I think starting with the bankful elevations, people sometimes get bankful right, but really mess up low flow, base flow. And so I would argue you should start with base flow and then build up to bankful, and that kind of your inner berms and other features. So, but you can make a stream more stable by making it smaller. That's so counterintuitive. As engineers, it's like, I make the stream bigger, velocities go down, shear stress goes down, conveyance, flooding goes down. That's what I need to do. I need to make this thing designed for the 100-year event or the 5-year event. No, you'll have a much more stable stream if you design it based on your hydraulic geometry that's supported by that watershed. So here's some pictures of making a stream more narrow. So this base flow is about 100 feet. We had just cleared the banks, a little bit of a road down to get into the stream, but really other than that, hadn't done anything. Here you see we're building off the side of the tower. I'm standing on the same ped bridge. Building off the side of the tower, still our access here. And so we went from 100 foot across base flow to 55 feet. Set one toe, we've got the other toe set here with some good compacted fill. Got a riffle built in, got some cross veins. There's the greenway on the other side getting constructed. And then here's that side built down. You know, you get a scale of this with the person here and the size of the boulders. Again, we got a cross vein here, but that cross vein has like 0.1 feet of drop. Again, because I don't want to turn this stream, it's a riffle pool stream. I don't want to turn it into a step pool stream by putting a cross vein in a tangent section, and then I've screwed up my pool to pool spacing, but I do need to create a little bit of a hydraulic movement to create a little depth diversity in there. So, and that's after the veg and there. So again, took a 100-foot wide urban stream, made the base flow 55, kept bank full about the same, got a no rise, actually reduced some flooding, and there. So when you make these smaller, you're doing a tremendous benefit for water temperature. There's some studies out there that's like 3 degrees Celsius will be the change. So we talk about global warming and climate change and how can we offset that. I think we can restore and narrow our streams a little bit in these urban environments, and we'll bring the temperature down. This is also a good way to offset. We did clear a lot of buffer and shade. So, this is a good way, probably it balances out the shade. So probably we had a spike in temperature due to the clearing of the buffer, and then we lower the temperature by narrowing the stream. And then over time, we'll have even more reduction in temperature as the shade and the trees come in that we plant. Building natural variability. I went and reviewed a project recently, and every single riffle was the same. So I asked the client for their plans. They gave them to me. They had one detail for riffles, and it was the exact same length, exact same width, exact same number of rocks. And the contractor built what they were told. They built the same exact thing. And so if you want variability, you need to have details that show that variability, whether that's putting in some boulder clusters. I love boulder clusters in urban streams, found amazing. Benthics, survivability, these fell out of popularity for a while, but the bugs, people tell me they find the best bugs in these boulder clusters, even though they're not natural to the setting. Logs work great. We put some root wads buried into our log structures there in the pool sticking out. So just a lot of variability, toe wood. So just mixing it up, having variability. Same with vegetation, good palette of native vegetation. You probably will plant. We mix our uplands and our riparian mixes together as those transition areas, because we're not sure exactly where the upland and where the riparian will start. So we just plant both and kind of let nature figure out what they like. So really the last step, is profile, plan, try to do everything you can in these urban systems to naturally do it, but then you kind of have to create some resistance and picking that right. So, here's some just examples of trying to be as green as possible. I see soil lifts a lot of places, and I'm like, you don't need that soil lift there. You could have laid it back at 4 to 1 and put a little bit of toe there, but sometimes you can't lay it back because you're against the sewer line or something, or in this case, we're building out the bank to protect that manhole and the sewer line behind it. Same thing here, we all hate riprap, but sometimes you gotta go in some boulder toes and riprap because of sewer. Here's the line here. This thing busted and we had a big sewage spill. So we had to build this super fast. And you see, we got a few places where we're quote unquote armored, but again, we brought the stream up, covered back up these lines, and replaced as needed some of these old pipes. Using plan and profile to stabilize. So right here, see this towers. I'm not sure you can see these very well, but there's high voltage transmission towers, super good at working in urban environments. The tower right here, just past this thing, the stream was underneath that tower, and Duke Power was pretty panicked. We moved the stream out, reduced the radius of curvature. But the big thing was there's a giant steep riffle that was just running right into that bank. And so it's super high near bank shear stress. So I don't think we think about it enough, but what we did was, we had to do a little bit of toe armoring, but all this is fill dirt. And what we did is we set this riffle downstream, we raised it up a couple feet, and took us a couple riffles to get it down. But we basically turned that slope around that bend back to 0, which is what it should be in nature, right? Our pool slope around those radius of curvatures. This radius of curvature does not meet design criteria. It's way too tight, but we have sewer line on this side. We have high transmission on this side. I'm standing on a bridge. So there was just a lot to kind of navigate it through, but resetting that slope was way better than a bank armoring technique, right? I think we instantly go to like, oh, the bank's eroding. What do I do? Soil lift, riprap, toe wood. It's like, well, sometimes just fix the profile and you get a lot of stability. Same thing with this bridge. This bridge was already there when we did this section of the creek, so we had to kind of make it through. You see that it's in a radius of curvature, not ideal. I would rather have a bridge crossing in a tangent section, but just how it fell. And so again, made a 0 slope underneath that bridge to minimize how much armoring we had to do under it. So thinking about your slope relative to infrastructure and stability, not thought about enough as we do these urban projects. I don't know about you, but I've never seen a pipe outfall in the wild. So for us urban designers, stuff we have to deal with is not natural. So, but what can we do? So this is Piedmont Park in Atlanta, Georgia. This is the Olmsted Park. So Olmsted designed Central Park. These are his sons, the Olmsted brothers, designed a lot of popular parks. Golden Gate Park in San Fran, Central Park. This is Piedmont Park, which is the Central Park of Atlanta. So this was a concrete channel. We daylighted and turned back to a natural stream, but this is a 42-inch pipe here in the top left. And I think Shamrock Environmental built this. I remember Tony saying, I've never built a waterfall before. This thing has constant perennial flow. You see a building up here and there's a parking lot that comes down into our stream corridor. This is just a vertical drop. So we built this bank out and we built a step pool. This is how it's naturalized in the decade. And it's funny, if you go on this, I just did a Google search on this, and this is Brittany and Greg, according to their wedding site. And this is a super popular place for people in Atlanta to get their engagement photos. And I really think most of them think it's a natural waterfall. But you know, it's funny, the photographer was pretty lazy. He didn't even crop out the 42-inch flared-in section at the top. So it's nice as a stream designer to be part of people's life's moments, and you know, to have Greg and Brittany here take their wedding photo on a step pool structure that I was a little bit of a part of, and it's beautiful. It looks really great. And, you know, of course, the Piedmont Park Conservancy does a great job in their vegetation management. So, you know, these have really turned into, you know, from quarry stones to look like natural rock and looks like a natural waterfall. So this is the challenge in urban settings. It's mixing these gray ideas with stuff that's going to stay because of that. Here's a regenerative stormwater conveyance at a site in Huntersville. You see, we got a little bit of our gravel that we top dressed it with to kind of get it some stability. Has washed into the stream, but that's okay because it did naturalize, and this was a big gully. So, you know, we've got an outfall here. So again, you're dealing with things you have to be thoughtful of. This is the biggest thing on urban projects I see, is when pipes or built environment comes into natural environment and not enough thought of how those two interact. Whether that's a utility crossing or a roadway crossing. Here's a right, this is High Point University. Did a little bit of a culvert repair, but did a little bit of stream restoration with it, and you know, replaced a undersized 36-inch RCP, maybe double 36s, I don't remember exactly, here with an arch culvert. Jason Diaz and Jake Mashoff did this project, and then we put in an overflow culvert that serves also as a greenway. So there's some cool things you can do with, you know, bringing people to the stream and you know, making something that works from a built environment, transitioning back to a natural environment. But a lot of thought needs to go into that. Respect the past, but plan for the future. This is the Piedmont Park. So we were trying to be true to the original plan from the 1800s that the Olmsted brothers put. They were really interesting to do that research. So the Olmsteds believe that nature is the center and the spine of a park. So whether that's Central Park or Piedmont Park, they wanted to make sure that nature is the center and the stream was the spine of the park. So they really cared for it and wanted it to be the centerpiece of the Central Park, Piedmont Park. But what happened is, you know, Atlanta has a lot of combined sewer overflows and a lot of urban stormwater. So this CSO, so we had to plan, be true to the park, but also be conscious that there's a CSO outfall tunnel. There's some treatment wetlands that we designed in for overflow. So we'll never get rid of this combined sewer overflows from downtown Atlanta. It would cost too much, but you know, a lot of them go into a tunnel up to the 10-year storm and then sent to the treatment plant. So kind of mixing in, again, that green and gray approach. Climate change is another thing we have to consider, future development. But we can be true to go back to my original slides, that our cities are founded on these streams, and they should be the front yard of our cities, not the backyard ditch behind somebody's house. But I'll remind you, the past wasn't that great. These are some cool articles when we were doing the Little Sugar Creek project thing of, you know, these are from 1969, pre-Clean Water Act, don't go near the water, loopholes can't halt pollution, waste pollutes county creeks, pollution cheaper than cleaning it up. I love this one, a sewer named Sugar, because this creek is Sugar Creek, Little Sugar Creek. And then so this has really kind of kicked off the efforts to clean up Charlotte's creeks, which were some of the most polluted through the 80s. And now are some of them headed towards some of the cleanest. Urban streams, you know what? People are our species of concern. I'm not sure, are we a native species or are we an invasive species? But sometimes both, right? Because I think those of us who've done urban design, we want to get people down to the stream. We want to make people get that river ethic. We want people to love them. We want all those people to think, I love this guy's fly fishing here in the Platte River right near my house. This is my wife and nephew. Took them on a tour to show off the work I did in Little Sugar Creek. There's just somebody taking photos randomly on Little Sugar Creek. Here's some ladies fishing. But we need to think about how humans interact. They will trample your vegetation. They will, homeless populations will bring a fecal connection. We really need to be thinking about all these people using the streams and how we want them to come in contact and really design connections that are appropriate and safe. So a little different there. And I'm not sure. Well, we can debate after my talk if people are invasives or natives. I would say natives. So my last slide, the last couple slides here is, those are my tips. I want to hear from you after this presentation because I'd like to incorporate some of these into the talk I'm going to give at the stream conference of what are some other things that we all can agree on, or if you disagree with these, that if we were creating a national standard would be in there. That's regardless of where you're working in the country, it's going to be true. But results. I hear too many times, urban stream restoration doesn't work. BS. It works. This is a EPA case study that came out at the end of last year. It was published in like November. So North Carolina, based on efforts improved McDowell Creek, and it's hard to read this, I know, but it's these efforts have led to an improved benthos population, promoting changes in water quality status. A 2.7 mile stretch of upstream Mountain Island Lake from a 4B, which is basically heading to a TMDL, compared with the management strategy, to a 1B meets water quality criteria with management strategies in place in 2020. So really cool case study. I did a ton of projects in this watershed. This is part of the McDowell Creek Watershed Management Plan. It's like Huntersville, Cornelius. This flows into the drinking water in Charlotte, North Carolina, which serves 1.1 million people. So it's super critical from, again, us being a species of concern, but also poor benthics. The crux of this plan, or the driver of this plan, was stream restoration. They've restored 7 of the most erosive and critical miles. And that water quality, there's also good low impact development ordinances that made some treatment plan upgrades. But they have changed this water from impaired, meeting a TMDL, to meeting water quality criteria. And this is a very suburban, urban watershed. So it can be done. And when people tell you it can't, they're wrong. There's case studies. It's just one of those, go-to sayings that we can't do that. So, I've been really fortunate to be around streams my whole life, or at least as an adult. I used to, when I was in college, love to go camping up in Humble Gorge. I got engaged on the Nile River, bottom left there, in 2009. I got married on the Snake River in Wyoming. I love rivers. I love urban rivers. But you know what? I grew up in Winston-Salem, North Carolina, and most of my time, my grandparents owned a tobacco farm, so I spent a lot of time there. But most of the streams I played in were just suburban streams. And, we lived in a quarter-acre lot with curb and gutter out front, but there were some cool streams behind my house that I played a ton in. And we need to remember this, that urban streams will likely be the only streams that in many kids' lives, right? There's 7 million kids living in poverty. 1 out of 7 kids will probably never get to leave their neighborhood because of economic conditions. So this is really cool. This is Stewart Creek. This is right downtown Charlotte. This is the Boys and Girls Club. This was just a big giant ditch. We restored it, picture on the right. There you see the Boys and Girls Club behind. We put these cool boulder steps down to the creek because they wanted to use it as some education and some connections. So hopefully, some of these kids, here's the football field you see, will not just play football and basketball at the rec center at the Boys and Girls Club, but they'll get out and maybe play a little bit in the creek like I did as a kid and fall in love with our urban streams and rivers. So we really need to remember that. One last slide. Go Nuggets. Play tonight. I hope we can take home the NBA Finals championship and close it out. And with that, I'll answer it for questions.
Hey, I just real quick comment. Will, that was great presentation. I appreciate it. I know a lot of people have a busy Monday and we might be running shortly over, but I'm sticking around because this is good stuff. I really like the beginning, your point toward the why we're restoring streams, and to me, it's like we're acting in triage. And while there are a lot of overlapping interests in urban settings, whether it's floodplain water quality, human use mitigation, or whatnot, those overlapping interests seem like they could develop some sort of momentum toward, but sometimes those turn out to be where all the tension is. You know, when you get into the details of the stream restoration, like you pointed out on the stream that was flanked by both the power line and the sewer line, and all these requirements for those easements. And so it's almost like, you know, educating each other, but like you said, educating our municipal providers, not just the administrators in our cities, but all of the people using the power companies and the sewer lines, and what we need to do. But yeah, I want to check real quick in the chat, and if anyone has a question, feel free to just chime in.
Anybody have another go-to that they would say is something we should be doing more of, the most common mistakes they see? These are just kind of stuff I've screwed up on and done wrong myself, putting drop structures or step pools in the middle of riffle pools, streams. And, you know, we've all learned from our mistakes. And, you know, I think seeing way too many beaver analog structures now. I think Dave Roscoe talked about that in urban settings. I'm like, no, not appropriate. But depends. I'm not going to say they're not appropriate, but headwaters.
That's the thing. Why we're doing it. Yeah, a lot of things get thrown in the ground. Money gets thrown at the project and problem. And I think you also touch on this in this presentation. I really like that you touch on the relationship, our relationship with the river, and the importance of creating those connections and restoring those relationships, because really good stewardship starts with caring, wanting to do the right thing for the right reason, and putting the stream first. And I really like you know, it's a very technical presentation.
You're crawling?
Hey, did they get that track hoe out?
It was ruined. It took 3 track hoes to get that track hoe out. That is an alluvial stream, by the way. It's just that's yeah, you see the mud mat to the right there where he fell off. So, you know, be careful where you walk. Yeah, that one got sent to the scrap heap for parts. Actually, I think this was North State. I think Daryl told me they sold it secondhand, and it still ran, but he wasn't going to use it anymore.
Also, to point out, you mentioned early on, I think a standards book and some standards is good. You know, NEH provides a National Engineering Handbook provides some standards, but I agree with you as far as application, not just here's a design process, but application. And I feel like a lot of money is being pushed toward the municipalities and those administrators to do something about their streams, while the mitigation industry has really driven a lot of research and development and practice and trial and error. I'm feeling a shift in the market toward those other municipalities. You know, we look at them and we say, oh, well, rather than just put a big pot of money for everyone to grab, let's funnel it through administrators that have that the administrative infrastructure, and they're responsible spenders. Well, you know, they're good people wanting to do the right thing for the right reasons, but you know, they're handed a handful of money sometimes and a very short fuse schedule, and with all these different overlapping interests, but underneath have underlying contradictions to resolve. So oftentimes you just see, you know, the wrong thing being done and money poorly spent. So,
yeah, I agree, Josh. You know, I think a lot of the drivers have been through the 404 side of the Clean Water Act, obviously with the recent Supreme Court decision and stuff there. But I think that the side where we can leverage in urban is in City of Charlotte. Shout out to them, has really done a good job of funding it both from the 404 side of mitigation, but also through their MPDS permit of MS4, which is still part of the Clean Water Act and Section 300s, to drive their spending and determining that they get a lot of bang for their buck from nutrients, whether that's nitrogen, phosphorus, or sediment, by restoring their streams way more than if they spent that same dollar in a regional BMP. They spend that same dollar on stream restoration, they get way more water quality benefits. And they've done the research and the fish monitoring and the benthic monitoring to show that these urban projects are making a difference when executed well. And that's the key, when executed well. Because if they're not executed well, then we're all going to watch this money disappear, because everybody's going to say, we turned an eroding backyard ditch into another eroding backyard ditch for $100 million or whatever we spend, right? And that's the thing, I think.
Yeah, and somebody just pulled some details out of someone's field manual from Roskin level 4, and so now natural channel design is not an option because it doesn't work, right?
Right, yeah. Right.
Well, we'll keep taking questions, but I want to point people who might be leaving. I'm hearing a few people are moving on with their week. You can see Will on August 21st through the 23rd. The conference, a big conference, great conference. If you've never been, you should go. We used to have these regional stream conferences all over the country, and we kept having, so it was 4 times a year. We're having a family reunion. So now it's only once a year, and it's in Baltimore, August 21 through the 23rd. I put a link in the chat. So yeah, definitely check that out. And if you can get in there and see Will and some of the other great presentations to come, visit us at the River Shared table and say hey. And what else is there? Anything else, Dave?
No, if anybody else has Will, do you have a little bit more time? I have some questions, or I can get up with you another time if you don't have time today.
Oh, Will, you're on mute. Let me see if I can unmute you. I can't unmute you.
Yeah, I'm good for the next 30 or 15 or 30, Dave. And shout out to Erin, who's on the call from City of Charlotte. She said City View still looks great. So yeah, I'll definitely give kudos to the city for, they had some problems and they fixed them and they spent the money to get there. And Jason Diaz and some of the colleagues I worked with did a great job of executing that project with Erin and her team.
Well, I have 2 questions for you, but I'm gonna wait until after it's a little bit silent for a while, just so that everybody else, if they have time constraints, they can ask their questions before the end of the hour period.
Okay. Yeah. I know I said some things I think I'm still vetting out. I'm curious if others are mapping out low flows. I think that's something I see a big mistake on. I struggle with too. I remember when we did Little Sugar Creek, we had a 2 or 3 day debate in our office of what was our low flow width. We knew what our total area was going to be, but we had no clue where to start from low flow. So we created some curves. We looked at stable sections. We tried to go in the winter. We tried to go in the summer, and it was still a head scratcher. And we got close. I don't know if we got it exactly right, but we got close. But that's always a struggle in urban streams. It's like, what's the low flow, because it's so variable. And low flow is obviously supportive of if we're trying to get back fish and benthics, we got to get low flow right.
If you don't know Will, feel free to reach out to him. He's easy to find. Just Google him, and yeah, he's easy to talk to. So yeah, that was a really good presentation, Will. That's great. Thanks for sharing that today, and thank you all. I hope everyone has a good, safe week and advance the mission.
Thanks, Josh. Dave, you want to stay on?
Yeah, I do. Yeah, and then anybody else that wants to stay on can stay on as well.
Thanks for the invite.
Bill, there's a question in the chat.
Oh, okay. How can you elaborate on how you encourage momentum and velocity idea in design? I think my first starting point is definitely to, the published values are great, and we should always lean into published values because it's going to give us much more criteria. Just know where that published value came from. So if you're using 5 feet per second, where was that established, and for what soils and in what environment? A lot of these come out of channels and flumes. I like if you've done a reference reach survey, model your reference reach and see the ranges of velocity and shear stress that you're getting in that, assuming that thing. I will caution you though, when you build your project, you're not going to have that willow root mass and that vegetation that's in that reference reach. So you probably need to, consider that you will need matting, or probably lower that shear stress and velocity a little bit as your project transitions and the vegetation establishes. So I always establish a reference shear stress, reference velocity to go along with my width, depth, area calculations from reference reach. And HEC-RAS 2D is a great tool to really dial in on that. We flipped the grid where HEC-RAS 2D was really made to make a tight grid in the floodplain, and use 1D or a bigger grid in the stream. We do a really tight grid in the stream, because that's where we want to know all the little cells and what's happening from velocity and shear stress standpoint in that 2D model.
All right, anybody else?
Flip the grid. I like that.
And I think the thing we're trying to do now that we haven't done yet, but is to go back now that these projects have built, some have been successful, is to model those post-construction and see what, because we've had some big events. We had the 2 gauges of record since we built Little Sugar Creek, Florence and Hurricane remnants of Hurricane Florence, Hurricane Michael in 2018, 2017, and see what kind of velocities and shear stress we got, because we know the projects are gliding them. So we know that, I believe it's probably closer to like 10 or 12 feet per second in some spots where you have good vegetation, but we'll see.
All right. Well, hey, Will, have you ever read the Loon Leopold's last paper, 41 Years of Geomorphic Adjustment on Watts Branch?
Mm-mm.
Okay. I'm going to send it to you. If you don't mind, I doubt you have a lot of free time. If you get a chance to have some free time, I'd like to talk to you about it. Essentially, it goes to the idea of changes of recurrence intervals from Watts Branch with the urbanization around the DC area. And I think that talks a lot to kind of the concept of we're not designed to return interval, we're checking a return interval. And I would like to create a small addendum to Mile High Flood District's sizing criteria to try to put a stake through the heart of that 70 times the 2-year discharge, or the 10 times the 100-year. I mean, 10 times the 100-year. I mean, we never see that in rural environments, much less an urban environment. And from all the urban stuff that I've been blessed to work with since 2005, I have never seen something with a high impervious area that had a return interval greater than 1.2. So
yeah, like I said, we're finding it like 10 to 15 bankful events a year onto what we would call our floodplain bench, or floodplain bench, I guess is probably a better term, is that floodplain is so associated in urban environments with the being a regulated floodplain.
Yeah, and and what we ended up doing, because of people yelling at us from different directions in Houston, is we found a higher geomorphic feature, a lower geomorphic feature, and then a very low geomorphic feature. So if you look at the Harris County regional curve, you'll see the inner berm mapped, no low flow, but the inner berm mapped, the bankful mapped, and then what we call flood terrace mapped. And then, of course, there's a regional storm above that. So I think that's what I've been trying to do with Mile High Flood District, is say, okay, well, we're going to give you a 4-stage channel, and yeah, our bankful channel does not fall anywhere near that 70% the 2-year. But you know what? Our flood terrace channel is 70% of the 2-year, and it has a slight different pattern off of it. So I think there's something where we can create a new something where they can listen to that, but I don't really want to use just that criteria, because I feel like the criteria that they're using of 70% of the 2-year has just been pulled out of the air at some point. And I don't think
it was probably back calculated from what they thought was a bankful channel, and I'm not sure where it came from. I'm sure it had some basis of design or they back calculated. Probably what they did is back calculate like the 1.2-year discharge to 70% equals 70% of the 2-year. I agree, Dave. I don't think, just get away from return interval and talk about what is based on the soils, based on the flow, what's the watershed's producing from a sediment and a water yield budget, from a hydrology and from a water budget and a sediment budget, and then what can those resistance of that material withstand. I think that's really what shapes the channels, right? It's like the channels finds that dynamic equilibrium where it can, it gets to be erosive, so I need to be on a floodplain at that point. And I think that's how I need to be thinking about it and that speaks to an engineer when you start talking about momentum, conservation of momentum and velocity.
What you point out, go ahead, Dave. I was going to say that's a good point.
I look at is the sediments have formed over thousands of years. So your sediment deposition in alluvial systems have been graded based on the flows that it's seen, which is related to the vegetation that can establish in an area. So even though you increase the discharge, you're not going to have the materials available to resist deformation, at all locations. Just, unless you have a really dense vegetation, you're not just going to not have those sediments available.
Right. And your sediments change, like I said, in most of these urban environments. It might have been an alluvial system because you had upper
Yeah.
parts of the watershed that was producing gravel and cobble, but all that's been piped and paved and it's gone. And so now the only sediment you're really getting in these urban settings, which I think some people take is, oh, it's moving sediment. Well, it's because there's so much instability and it's just all bank erosion coming down to you. And they miscalculate that as watershed yield of sediment, and it's really just bank erosion. So yeah, it's an interesting dilemma. So, no doubt that the sediment budget is changing and the hydrology is changing. The question is the channel form changing? In my opinion, based on, again, this is really North Carolina bias because I've done the most work there and I've looked at the curve, but I mean, we've looked at hundreds of references and 20 plus projects, and they've always been pretty close to that rural curve, which I think is a really solid curve. And we found really good alignment with that. It's just the return interval varies from, like you said, 20 bankful events a year to 1 bankful event a year, somewhere in that ballpark.
Will, would you be willing to help out with putting together an addendum to Mile High Flood District stuff with myself and Troy Thompson?
Yeah.
Cool. Well,
Yeah, that's a good point. The local policies, Dave, like you point out, those I see those are where we're having our biggest challenges. Down in Texas, they have policies that were inspired by flooding that are acting as constraints to design. We have policies, where people are like, oh yeah, there's a big giant head cut where there was a wall, but you can't change the velocity of the flows upstream or downstream when you restore it. And that's I mean, based on momentum and continuity, it's relatively impossible. And so these policies become hurdles, and often we see urban streams being designed to permit. That's another administrative, there's a lot of these invisible risks that get introduced to a project once people start to actually put it on paper. And that's where a lot of our urban projects are suffering and failing. It's not so much that we don't understand the physics of a stream, but we're actually trying to, engineers are designed, our job is to make a solution and make it readily available. And we're pulling these books and tables and applying these treatments in a fashion. They think they're using a good resource and they're trying to do a good thing, but the craft cannot be separated from the service. It can't be a commodity. And in fact, it boils down to the relationship with streams that we have. That's not a commodity. That has to be something that's nurtured. And so should each stream project. So these invisible risks that appear are really our biggest hurdle. We understand how to build streams and what streams want and need, but putting them in the urban environment, I like this talk, Will, is a real special challenge. And I like the cases you present in North Carolina. The McDowell watershed is one where I would go back to what's his name, the research scientist at Mecklenburg County, Dave Craning.
Yeah, he did the plan, him and Brian Sykes, and who else worked on that?
Yeah, they have
Rusty.
a relationship with that watershed. They've studied it intensely, and they get it. And so that is a great success story that you share. That's your fingerprint here, and one of your stronger fingerprints. So I think that's
Well, that plan was done in like 2006, and it got off the TMDL. It moved off heading towards it. Their TMDL avoidance plan was successful 15 years later. So it's not, I think we're looking also I restored this stream and 5 years later, my bugs aren't great. It's like, well, be a little patient. It's okay. I'm not sure it's going to recover that fast. And usually I think people are also saying, oh, it recovers. And then I've seen a lot of ecologists pointing out stuff's recovering and then it's falling off again. Well, maybe does it come back? I mean, I don't know if we're making these conclusions pretty quickly without the data. And I think that's a great case study of there's way more than just the stream restoration, but the stream restoration was the intervention and then policy kind of wrapped around it. There's a little bit of upland BMPs, but not many that really go to that water quality change. And, I think it was like they restored 7 miles, the worst 7 miles of, I don't know how many miles are in there, hundreds of miles of stream channels in that watershed. But just by hitting this worst 7, they got rid of so much sediment and so much nitrogen, so much phosphorus with that sediment that it recovered.
Yeah, the community embraces that residential community. They're they know, they understand now. I mean, it goes to our drinking water, and that was a real driver, but
Yeah.
you know, that's really great. It's actually defined the community.
Hey,
Yeah.
I have one last question, and this is kind of more something to think about and ruminate over than anything else. Is it possible, you know, we talk about words like revival and stuff, and whenever we talk about a revival, we're saying we're coming back to something that we'd found important or value in the past. And when I think of how how Mesopotamia is on two rivers, and the idea that most developments were on rivers, and rivers were a key part of urban environments. And now if you go to a lot of urban environments, especially in disadvantaged communities, people don't even want to be near a river. They just want it to go away. There's something over there, but they don't want to know what's in that ditch, and they just want it to go away.
Right. It smells, it floods them. It's bad.
So how, as being a river restoration person or a waterways person, do you think restoration helps with kind of a revival of the thought of what water is in a community meaningfully, or you think it's just kind of like, they're still going to think it's a ditch?
No, I think it totally reconnecting people back to those waters in a way that it's not a ditch anymore, and it actually has ripples, it has sound, it has greenery. It feels like a stream or a river. We've seen it, and it's pretty cool that, you know, kids playing back in the creek. And to me, you create 1 million river watchers if you connect people to the Platte River or the Thompson or whatever, the Little Sugar Creek or whatever it is, and you get them connected back to that. They want to be down there. And then if the water's green and brown, they're going to yell about it, right? And then that's just going to cause city council to be like, hey, we need to clean this up. So I do think, Dave, it is getting people reconnected to the river, especially kids, that's how we're going to create a river ethic in urban environments, and not be this thing that can kill me, flood me, pollutes me, makes me sick.
Threatens my buildings. Yeah.
Yeah. I mean, Stephanie Roberts, I don't know if she's on. She was a PM for the Stewart Creek project, which is really downtown Charlotte. It's sort of gentrifying right now, unfortunately. But that project was stalled for years because they formed a committee, and they thought this is true, and this is where we're dealing with. They thought the county and the city were putting AIDS in their water, and that was actually being passed around like HIV, and they were trying to harm the historic African-American community there. And Stephanie did an awesome job of diving into that neighborhood and rolling her sleeves up and just going door to door and getting them on board. And they were our biggest advocates. They were called the Stewart Creek Environmental Foundation, or Historic Stewart Creek Environmental Foundation, something like that they had formed as a neighborhood. And we got them engaged, and they were all about it. And they love the project now. So it's a challenge, but I think like I said, that blue mind, we just want to be around water. Here's a book if you haven't read it.
It's true.
It's just in our lizard brains now. It's just like, oh, I feel safe, I'm around water.
It's true. There's it helps to release free radicals. People, when you're next to the ocean, the air actually, I'm understanding the physical, not chemistry, but the physical nature of the air and the space around moving water is very dynamic and healing. And yeah, you're right. I agree. So do a lot of people on this call. Dave Woody's here, and he's been serving that mission well.
I put Dave Woody in my presentation. He was the after model in my Davidson project. It was me, the before model standing in the size channel, and good looking Dave Woody in the after.
Thanks, Will.
He's got a much better hat.
Well, I do want to make a quick comment too on the aftermath of these projects that we've done. It is bringing a lot more community awareness. And Stewart Creek, I was just out there 2 weeks ago, and it just looks so amazing. Once you lay the banks back and you get new vegetation established and you can actually see the water, it brings a whole new mindset to what you would have otherwise thought was basically an open sewer. I mean, that's the way some of the streams get categorized in the inner cities with what they're doing. But this is definitely promoting a big thing. And then back to McDowell Creek up there, you know, that just keeps growing. The vegetation looks amazing down at the confluence at Torrance and McDowell. Right now, they're actually installing a greenway there that's going to bring a lot more public awareness to the whole region. So, you know, it's a little step at a time. And the last thing I'll touch on, it takes years, if not decades, for things to get back to a natural equilibrium, if they do. And some of the monitoring that we're doing, you know, you can't fix a stream or go out and do the construction and think that the aquatic habitat's going to be fully established in 1 or 2 years. It's going to take a long time for that natural existence to come back around. So just want to put those 2 cents in.
You know,
Dave, are you aware? I think you guys have done for my knowledge, probably one of the few places that's basically had a TMDL. You guys avoided that with your 4B plan, and then now it's back to a 1B. I mean, I don't know of another stream, urban or rural stream that's moved off that list. That's pretty awesome.
Yes, I can't think of one either, but that was a huge accomplishment to put all that whole string of projects together and then to be lifted off that list. That's
you know, that's something worth highlighting and raising. I think a lot of communities would look to that and be like, how did you get there? You know, what was it? You know,
Right. Because having a TMDL is so financially burdensome if you get one. I mean, I'm talking to Greeley, Colorado right now. They're getting ready to hit with a TMDL for fecal, and they're panicked, right?
Well, what about the benefit to the property and the real estate? And I mean, is there a return on the taxes? I mean, if you think about those,
Oh, yeah.
if they've lost value, you're going to lose your tax, but you're increasing the value. I want to say one thing I want to breathe before I forget is Will, maybe in your presentation that maybe a point toward the administrative client, you know, the administrative partner. You know, David, you work on a lot of projects, and you know, Charlotte and Mecklenburg work on a lot of different stuff. And not to embarrass you, but the truth is, David, you have a special gift when it comes to collaborating and rounding up folders, and I think that's a real important piece to a lot of the success on these projects, is having that type of a not educated, I don't know, you have a gift for neutralizing and for collaborating, and I think that's a special piece of it, that, you know, to connect the technical to the ground. Really.
Well,
for sure.
Thank you for that. It seems like a lot of the projects we do, a lot of the project managers don't get the recognition that it took to lift these projects up to the point of being constructed, because, you know, like Will touched on, Stephanie did a lot of background work just to get the public's trust and interest in these projects. And we all do. I mean, our whole team, whether it be the city, it doesn't matter where the project is across the country. In these type of projects, you're having to sell the project, unfortunately, and it takes buy-in from the communities, and you have to do a lot of PR, a lot of legwork. And you know, Stevens Creek was another big one. I had to get 60 plus easements out there, and I was sitting in, you know, at the kitchen table and talking to the families and trying to you know, convey what the project was going to look like without having a full design set of plans even started yet. So you can't make promises that are going to be unkept. You've got to be real with them. And we always say it's going to look like a bomb went off in your backyard, you know, when we come in and trees go down, dirt's exposed. But now everybody's like, oh my gosh, this is unbelievable, you know. But it's hard to convey the future in a 2D conversation.
Well, and you're the one sitting at the kitchen table, and when you're there, people get a real sense of your genuine nature, or what is your intent. So if you're an administrator that's trying to, like, this is best for our budget, this is best for, you know, the city, and you know, that goes back to doing the right thing for the right reason. And when people get a sense of that, they might say, well, I don't fully understand, but you sound like you're gonna keep this parade going until it's done right. And then it goes beyond those stakeholders. Dave, when it comes to contractors, I mean, as the project owner, that's a whole nother challenge. And having the administrator, the municipal stakeholder having a good handle on that contractor, that makes all the difference. You guys have contract requirements that might preclude you from picking your favorite contractor or the best contractor. So I think that's another big point too. During construction, there's always a lot of potential compromise, more invisible risk to the project. Oh, we'll use this stone instead of that, or we'll just replace this with that, or
Yeah, and I think the interesting thing that both of you bring up that, we haven't even talked about, there's a big push now in infrastructure, it's in the infrastructure bill, about equity and inclusion in these projects. And the Stewart Creek project was driven by most of the county projects due to property and not having to get so many easements, were in sort of suburban, Huntersville, Cornelius, Davidson, but not in downtown proper. And Stewart Creek did that. And it was interesting when I was doing research for the Piedmont Park, the Olmsted brothers believe that natural environments and natural parks and our natural open space is the space for all people. Whereas like traditional parks, which were like, think of like Versailles in France, and these like very arrogant and constructed and like very royal and noble, but aren't for all people. They're only for the rich and wealthy. And so I really think that's a cool selling point too, is like you create these greenways and these linear parks, and it's a place for everyone to go and everyone can have access. And Stewart Creek is a great example of that. And got, all these linear projects, Little Sugar, these are projects for the whole city to utilize and to feel part of, especially when they go through neighborhoods where they can use them as transportation corridors, they can use them as backyard green space, stuff that isn't available in those in disadvantaged communities. And so, there's a big push in infrastructure, whether it's a road, whether it's water, sewer, anything now, is to make sure that we're not dividing cities, but actually thinking of that equity and inclusion piece. So I think these projects are a great example. But, I will say I've worked in a neighborhood where we were trying to put bike lanes in, and they were like, we just want to walk to the bus stop. None of us own a bike. What the heck are you doing? So we still need to be thoughtful that, we come in these neighborhoods that don't have a lot of money spent and we're doing stream restoration. They're going to be like, can you get me a bus stop? So, there's going to be some of that too.
That's really good. I'm going to bounce. Maybe if anyone wants to continue discussion offline, it's good to see and hear from you, Will. Look forward to next.
Yeah, I'll see you in Baltimore. David, good to see you, buddy.
Yeah, I hope so.
Yeah, man. Yeah, I plan to be in Baltimore as well when we're going to.
Okay. Shout out to you. I mean, most of these projects you guys funded, it's a few city, a few county, and few from out of state. But anyway, you guys are doing cool work. And when Sykes sent me that article from EPA, I was like, finally, I have some proof that urban stream restoration works. EPA says it works.
Man, that's awesome.
That's right.
When was that published?
End of last year. It's a case study on their website. So I think it was like fall, spring. It's funny, the data is from 2020, but the case study was published in. Isn't that right, David? I think it came out last year.
Yeah, that's correct. I'll reach out to Craning and see if we can get a link to share with this.
If you got Craning to put together the whole story, how you got there, man, that'd be something he wants to hear.
Yeah, I'll reach out to him. I think he did a summary on that, so I'll forward that to you.
Yeah, that's got a lot of pieces to it, but certainly the policy is a big piece of it too.
You could do a whole session on that.
Yeah, it's awesome.
Anyway, all right.
Two decades of our lives. That should be the name of it. Craning's for almost 3 decades of Craning's career, basically.
Hey, Will, if you want to get a copy of the recording, Amonte here is she's shown us River Shared. Reach back out to us.
Okay.
We get you a copy if you want to see. I mean, you said you're preparing for Baltimore. It looks like you're ready, honestly, but
I gotta whittle it down. And I want to add some more things and thoughts and make sure got it thing. But yeah, my name on my slides is 27 years and 27 slides. So I got to get it to 27 slides.
Yeah, good luck.
Oh, yeah, yeah.
I'm realizing
Like,
it's harder. Some of those will have to get consolidated. So anyway, yeah,
it's
if you
good.
send me
It's a
that
good-
link after this presentation and I'll share it.
Thanks, man. Thank you guys.
Thank you all.
Thank you all.
Great conversation.
You too. Good to hear from everybody.
Yeah,
Thank you, Monty.
thanks, Dos.